The idea of a black hole was first proposed in 1783 by an English parson named John Michell and was later predicted by Karl Schwarzschild in 1916 using Albert Einstein's theory of general relativity. Since then, we've made remarkable progress toward understanding how black holes work, helping us better make sense of the relationships between space and time. However, it wasn't until 2017 that we got the first bit of photo evidence of a black hole, which bluntly depicted the bending of light around the event horizon. How is a black hole created? There are two main ways this can happen, which seem to be quite polar. They can form by A, accumulating an incredible amount of mass in a given amount of space, or B, shrinking a given mass down to a minuscule amount of space. It's important to note that either process ultimately involves density, as we are measuring the relation between the volume, simplified into the radius of a sphere, and the mass of an object. When we talk about shrinking down a mass, we mean increasing the density of the object by keeping the mass constant while decreasing its volume. Both of the avenues to black hole formation depend on something called the Schwarzschild radius of an object. The Schwarzschild radius describes the event horizon of a black hole, which marks the outer edge from which nothing, not even light, can escape the immense gravitational pull of the black hole. Importantly, though, if an object shrinks down to about or beyond its Schwarzschild radius, constantly increasing in density, it will collapse into a black hole. So, if we wanted to turn the Earth into a black hole, we would have to shrink the planet down to a size smaller than the length of a dime, all while maintaining its original mass. Good luck. I think it goes without saying that no human is capable of that, regardless of what you might bench. Unfortunately, that means that either you'll have to walk to go buy groceries, or look away while you buy gas, or maybe take public transit to help out the environment. Yet the big concern here isn't that creating a black hole seems impossible for humans to do, but it seems unbelievable that a black hole can be created this way at all. It's not like there's a way around the math. The formula remains the same for all celestial objects, and thus all calculations would follow the same scale as the one we just carried out for the Earth. So then, how do black holes form? Black holes are a product of the death of a massive star, typically multiple times as massive as our Sun. So, to understand how stars die, we must first understand how they function to stay alive. Crucially, stars aren't rocky like the Earth. They're masses of densely packed gases, which by themselves don't hold any definite form. The large gravitational forces of stars are not limited to planets and asteroids, but also act on the star itself, which is what gives them their characteristic spherical shape, while simultaneously wanting to condense those gas particles into the smallest volume thermodynamically favorable. However, if the latter were to happen, we wouldn't be able to see many stars at all. So there must be a contradictory force responsible for expanding the gases in a star, ultimately resisting the pull of gravity. And indeed, there is such a process. Nuclear fusion acts as the stellar power source. At the core of stars, with incredibly high pressures, temperatures, and energy, atoms fuse together to form new atoms and release energy in the process. Oversimplifying, hydrogen fuses with hydrogen to form helium and excess energy. Helium then fuses with other helium atoms to form the next elements on the periodic table, which then follow suit to continue to merge nuclei and produce new, heavier elements, as well as a constant outburst of energy. This consistent energy output propels gases outwards, and thus, a star can expand against the forces of gravity. Great. So we have gravity, which pulls the star's matter inwards, and nuclear fusion, which pushes the star outwards. What goes wrong to make a star die? Well, it turns out nuclear fusion doesn't continue indefinitely. In massive stars that can progress through numerous stages of nuclear fusion, atoms will eventually fuse to form iron. However, iron just so happens to be the most nuclearly stable element in the universe, and cannot undergo fusion simply because it would require a larger input of energy to fuse with another atom than it would release as a product. Thermodynamics strikes again. So, once there is a buildup of iron in a star's core, nuclear fusion will drop even just momentarily. But at that moment, gravity, which acts as quickly as light itself, completely takes over the force balance of the star and causes it to condense and condense until its entire mass collapses in on itself, thus becoming a black hole. Now, this might seem familiar. As gravity takes over, The mass of the star doesn't change, but the volume it occupies in space decreases until the star is small enough to approach its Schwarzschild radius and become a black hole. However, not all star deaths result in black holes. Smaller, less massive stars have a more stable decay, becoming dwarfs in a process that takes billions of years, much like what will happen to our Sun. Not all black holes are formed from the collapse of dying stars either. Two incredibly dense, yet small neutron stars colliding and joining mass could assemble a great enough mass in a small enough volume to surpass its Schwarzschild radius and form a black hole. After all that we've learned about black holes, there is still one major observation that we cannot seem to explain. One baffling, yet terrifying origin. Picture the Milky Way, our home spiral galaxy. Now try and imagine the center of the Milky Way. Do you see a star? Maybe a massive planet? Maybe a solar system? Or maybe even nothing at all? The question astronomers and astrophysicists have been trying to answer since we've learnt the answer to the previous question is, why is there a supermassive black hole at the center of most galaxies? It's weird to think the Milky Way spirals around an enormous black hole with a radius of 12 million kilometers. Perhaps it's scary, but perhaps it's poetic that everything we know orbits the closest thing we have to pure nothingness. Thank you so much for coming this far with us. See you soon again, the next day, in the next video. Until then, good night, and remember to dream big.